Okay, and we're back looking at the normal distribution, but we're leaving the standard part behind. So here we're going to be messing with problems where we are working with a mean and a standard deviation and some value where the mean is not 0 and the standard deviation is not 1. This is really not that much different, but I'll show you how to work with those problems using the same tools. You're going to go ahead and do probability simulation, choose the little probability drop down, probability calculator, and continuous. And now say we had a problem where we know like the mean is 500 and the standard deviation is 100. And we want to know like what the probability of our value being less than 700 is. Go ahead and fill those values in. Click the checkbox for graph and click the preview. And here we go. So the probability that x is below 700 equals 0.9772, which makes sense because with our standard deviation of 100, 700 is 2 standard deviations up, right? We can go back and play with the values by hitting the basics tab again and say we wanted to change this, keep the same mean, keep the same standard deviation, but we're interested in what are the chances of getting a value between 650 and 700. We'll click our preview button again, and we're going to make sure I did that right. Oh, it's just slow loading. Yep. Okay, so probability that it's between 650 and 700 is 0.04406. So right around 4% chance that the value will be in there. We can go back and say, well, what if the standard deviation was a little bit bigger? Like, let's say it was 150. And then we can preview. And let's do the chances. The probability here is 0.06744. That makes sense because we are closer to the center of this normal distribution. I'm going to play with it again. If we made our standard deviation 50, look how far off to the side we are. And it doesn't even have space to show the 650 and 700 in our graphic. And it makes sense because our probability now is 0.001318. We can change our mean to be 650. And because now we're looking at the 650 value as our mean, we've sort of centered the curve right around there, and now our probability is equal to 0.3413. So I guess going through these several examples here, I'm trying to show you that this is a tool that you can rapidly play with and move from problem to problem, or sort of just tinker around with to see what changing the different values does. Notice that it's always, because we're using the normal distribution, you're always going to see this bell curve no matter what you do with those values. It's just a matter of where you are on the curve, and where the curve lies are determined based on the values that you've entered here.